Well, wonderful to be with all of you. My name is Jessica. I'm a certified brain injury specialist. I work for the Brain Injury Association of New York State. I want to encourage you to ask any questions as we go along. If you think of questions or comments after our time together, please do not hesitate to reach out to me. There's my phone number and my email. And I will send this presentation to Jen to send to all of you if you would like it. So we have a lot planned for today. We're going to take a tour of the brain. We're going to explore how it works and how it gets injured, for instance, in chemo brain. And then we're going to delve into dementia. And finally, we'll wrap up with how to take care of your one and only brain. Before we dive in earnest, I want to convey a few key concepts that will be important for our time together. By default, our brain is inattentive. In a group of this size, there is at least one person right now who is thinking something like, are we out of milk? I feel like I just got milk. No, I was going to get milk and then I decided again. So if that is you, you are not a bad person. That is how the brain behaves. It is always flitting around like an unruly toddler from thought to thought. That's what it's supposed to do. You may say, well, what does this have to do with memory? Well, in order to remember something, we need to pay attention. If you get nothing else from this talk, I want you to get this. It is literally impossible to remember something that you never paid attention to in the first place. It takes a minimum of 8 seconds of focused attention for the brain to make a memory. We are most likely to pay attention to and thus remember things that are new and things that are meaningful to us. Memory is a paradox. It is simultaneously important and not important. On the one hand, memory is important because it forms our identity and fosters our relationships. My memory tells me who I am, and if I know you, my memory gives me a shared history. On the other hand, our memory is wrong a lot. And I'm not just talking about, me with my gray hair. I mean, even young, healthy brains are wrong a lot. Their memory is inaccurate a great deal. And yet life goes on, even though a lot of what we think we know is incorrect. Moreover, memory fades, but love lasts. Even deep into dementia, when a person no longer knows who we are, they know that they love us. Just one more preface slide here. I'm asked a lot, how do I know what is typical aging? What might be from a brain injury like chemo brain, or what might be dementia? So I'd like to briefly explain each. Typical aging is gradual. Starting in our 30s, yes, you heard that right, Starting in our 30s, our processing speed slows, which means it takes longer to learn new information and longer to retrieve stored information. Also starting in our 30s, we have a tougher time blocking out distracting stimuli and sustaining our focused attention. That is important because, as we said, you have to have focused attention in order to make new memories. So that's typical aging. Brain injury means that sometime after a person was born, something came along and changed the structure or function of the brain. An example is chemo brain. Brain injury has a date. There is a date that a person got a chemo treatment and things affected their brain cells. And brain injury does not progress through stages. By contrast, dementia has no date. There's no one date you can point to say, this is when this person developed dementia. Instead, it progresses in stages as it spreads through the brain.
I'm not clear on the difference or exactly what you mean by chemo brain does not progress. Do you just get to where this is as bad as it's going to be? And then I stopped my chemo about almost 2 years ago today. Does it then no longer get worse?
Correct.
Oh, okay.
So the chemo brain is, for anyone interested, is something we covered in detail last year, September of 2021. So in the list for Living Well with Cancer workshop presentations, there's one called Chemo Brain, Challenges and Strategies. And so if you're interested, you could take a look at that one. But what happens is the neurotoxins in the chemo affect brain cells, but they're affecting them in the moment of the chemo. Now, sometimes there can be lasting effects, but it's not deteriorating over time. Versus, as we'll see, most dementia is caused by abnormal deposits in the brain.
Right.
And those abnormal deposits spread from one region of the brain to another. And as they do, the person's function degrades further and further.
So you're saying that if my wife is accurate, and if I do have memory issues, this is as bad as it's going to get. It's probably not going to get worse as time progresses.
Not from the chemo brain. But hey,
right.
There's still time to develop dementia. So
great. This is a wonderful talk. Thank you.
Aren't I just the bringer of sunshine? But yes,
Thanks,
from the chemo brain itself, you've had the injury that you're going to have.
Okay, thank you.
You're very welcome. Any other questions on aging, injury, dementia, the difference among them? Okay, so off we go on our tour of the brain. For our purposes today, the brain has 4 major parts. At the top is a large cerebral cortex. If you unfolded it, it would be the size of a standard pillowcase, but it's all folded up to fit in your skull. And the cerebral cortex is the fancy part of the brain. That's where we have speaking, thinking, reading, writing, relationships. Then in the center of the brain is the limbic system. This is sometimes called the primitive or animalistic brain. This is the center of fear and rage. Hitched to the back of the brain is the cerebellum, which coordinates the body's movement. And then coming up out of the spinal cord is the brain stem, which keeps you alive. It controls the basic functions of life. I just want to briefly show just a little bit more detail, because as we talk about injury and dementia, we're going to revisit these parts of the brain, so it can be helpful to know what is where. So the brainstem controls the basic functions of life: breathing, heart rate, blood pressure. It has your consciousness, your awareness of yourself and your environment. It regulates your sleep-wake cycle and allows you to pay attention and concentrate. Next is the cerebellum that coordinates the body's skilled motor activity. So things like walking, dancing, moving your body. That large wrinkled cerebral cortex that we just looked at breaks into 4 sections called lobes. At the back of the brain is the occipital lobe that coordinates vision. So this has your ability to read. On the top of the brain is the parietal lobe, which has your sense of touch and taste. And it also gives you your spatial perception, your ability to understand your environment and recognize familiar places. Now the big one, literally and figuratively. The frontal lobe is 1/3 of the brain. And it has some really prime functions: judgment, impulse control, our personality, mental flexibility, so the ability to adjust our perspective and look at something in a new way. Very important functions in the frontal lobe. Last, temporal lobe. Hearing, a lot of long-term memory is in the temporal lobe. Your ability to produce and process language, music, and putting things in order. If you put your socks on before your shoes, you have your temporal lobe to thank for that. Any questions about what is where?
Are we going to be able to get these slides later?
Yes, Al, I'm going to send these to Jen, and then she's going to distribute them to you.
Great. And the one that you mentioned from a year ago, or roughly a year ago, the basic one, is that available somewhere?
It sure is. On the Cancer Resource Center webpage, there's under Living Well with Cancer. But you know what? You've given me a good idea, Al. When I send my note to Jen, what I'll do is just put a little link in there for where you can find the one about chemo brain.
Terrific. Thank you very much.
Thank you for asking. Any other questions?
Hi, this is John. I got a question.
Yes.
I'm interested in autism or Asperger's, and if that affects any specific lobe or if it's generally spread out to others.
That's a great question. Those are in the frontal lobe. Any other questions? Okay, so this is looking at the brain kind of from the side, and getting a good big picture view. Now I want to look at it a little bit differently, like we're looking down on top of it. And I want to talk about the different halves or hemispheres of the brain. I'm going to stay on this slide for a bit. There's a lot here that can be helpful to us. So for starters, I'm talking about the large wrinkled cerebral cortex at the top of the brain. It has two halves called hemispheres. Each hemisphere controls the opposite side of the body. The left hemisphere has the past and the future, your awareness of the past and the future. The right hemisphere knows only the present moment. So I'm going to say that again. The left hemisphere is the past and the future. The right hemisphere is the present moment. The left hemisphere has your inner voice. Do you have a voice in your head? I feel like most of us do. Like, do you can hear yourself talking, like you have thoughts in your head? Inner chatter and inner voice, that is in the left hemisphere. The right hemisphere has inner peace. So if you've ever had a moment where you feel just tranquil, at ease, all is right with the world, that is your right hemisphere doing that. Okay, so far we've said the left has the past and the future. The right has the present moment. The left has our inner voice. The right has inner peace. I'll do one more set of that. The left has talking. The right has singing. The left has walking. The right has dancing. So there's a division of labor between the hemispheres. You may have heard, oh, this person is left-brained or this person is right-brained. And you can see in my illustration that a lot of that holds up. In the left hemisphere is where we have logic and verbal ability, math, rational thinking. And then in the right, we have art, music, peace, joy, love, fun. Why am I making such a big deal about what is in each hemisphere? I will tell you. It is because usually the left hemisphere goes offline before the right. Of the two, if one is going to get into trouble, it's going to be the left hemisphere that malfunctions. So I'll give you a good example here. Language. Most of your vocabulary, most of the words you know, are in the left hemisphere. But the right hemisphere has 100 words. Isn't that interesting? Most of your language is on the left, but your brain has this little pocket in the right hemisphere that can hold 100 words. To make it easy on my memory, I'm going to start each of these three categories of 100 words with the letter S. So the first kind of word that's on the right are simple words. I, you, me, the, thing. Simple words. Second S, swear words. Curse words are stored in a separate part of the brain than typical language. I'm getting some nods of recognition here. And last S, I'm very sorry to say, is slurs, words that insult other people, ethnic epithets, racial insults, slurs against people. So if a person loses function in the left hemisphere, they may lose most of their vocabulary, but they can still say simple words, they can still swear, and they can still insult other people because that's in a different part of the brain. So to give you two examples of where the left hemisphere lets us down, strokes are usually in the left hemisphere. And dementia degrades the left hemisphere first. So if someone has a stroke or they have dementia, there's a pretty good chance their left hemisphere is not going to function correctly.
Jessica, can I ask you two quick questions? This is Myra behind the dark screen.
Okay.
Sorry.
That's okay.
So part A is the reason for that because there's more blood flow to the left hemisphere because it's used more, and is the second question is, what about writers who use a lot of words, but they have to be creative?
Oh, okay. So no, for the first one, are you asking about strokes or dementia?
Well, why would the left hemisphere be more affected than the right hemisphere, I guess is the question. Maybe it's off topic, but I'm just curious.
No, it's not off topic. And you're right, there is more blood flow to the left. So there's more ways for things to go wrong. A stroke is a problem with blood in the brain, either too much blood or too little blood. And so when something goes wrong with the amount of blood in the brain, it causes a stroke. And that is more likely to happen, as you say, because of the increased blood flow on the left.
Okay.
Yep. And I'm going to answer your second question about a writer that uses lots of words, but is also creative. I just want to double check. You've got a good sense of timing because that's my next slide, but I just want to make sure, is there anything else from this slide before I go forward?
I have one question.
Sure.
When you said that each half of the brain controls one side of the body. So for example, the right side of the brain would control the left. Like, what if somebody's left-handed? Would that be related to the right side of the brain? And vice versa, if you're right-handed, would that be more connected to the left side of the brain?
Yes. Yes.
And is that an indication, if you're right-handed or left-handed, of which half of the brain is more predominant for you?
Yes. Yes. If you read statistics, left-handed people tend to be more creative. I mean, I happen to be right-handed, so that's not an insult against right-handed people. But yes, whichever hand you write with, it's the opposite side, the opposite hemisphere that's controlling that and is more dominant in that person. Yes.
Great, thank you.
You're welcome. Joellen, do you have your hand raised?
I do. Thank you. So you may be getting to this if you talk about dementia more, but is that those simple words on the right side, is that why oftentimes Alzheimer's patients, dementia patients swear a lot, even though they might not have been like that in their prior?
100%.
Okay,
You're exactly right.
okay.
You're exactly right. And even, and again, I know it's an unsavory topic, but even using slurs against people, which they might not have done in an earlier time. Yep. And I will tell you, sometimes even with something like cursing, the person doesn't even necessarily mean it in an emotional way. It's just they've only got a few words to use, and they're just trying to pick the word that comes the closest to what they're trying to say. I had a guy who had a stroke, and to start with, he couldn't speak at all. And when he could speak, the only word he could say was coffee. And he hates coffee, but every time he said coffee, people would bring him coffee. But coffee was the only word he could say. So he was just trying to communicate. So I understand it can be very unsettling to be on the receiving end of curse words or certainly slurs from a person with dementia. But one thing I think that can soften the blow is to realize this person is trying to communicate, and they don't have a whole lot of words that they can use to try to convey their sentiment.
Thank you. That's really helpful. Thank you.
It is. Thank you. You're all being such a good sport about this because I wanted to drill down on some things like this to demystify the brain and say, this is why this is happening, because I do think it does help to bear with difficult things to understand why something is happening. Yeah. John, do you have a question?
It's Janice, the wife again.
Oh, hi, Janice. Yes.
Jessica, this is a wonderful presentation. I'm curious what evolutionary purpose would have been fulfilled by the right brain maintaining that small, very unique vocabulary.
Excellent question. It is because the brain often does this, where it has the main function in one place, and then it has kind of a backup system somewhere else, precisely so that if something goes wrong with the other hemisphere, there's a backup plan to say, okay, I can still do the basics of that function, in this case, communication.
So those
Does
would
that
be sort of
answer the question?
basic protective words. Leave me the
Yes,
alone.
exactly, because basically, if we get really down to primitive brain function, where we're talking about survival, that is driven by fear and rage. So you need swear words for rage. You may even need some slurs for rage, and you need simple words if you're in a fearful situation, you don't have time for supercalifragilisticexpialidocious. You need a short, simple word to convey something. So yes, it would have been developed that way to protect somebody's ability to communicate in a dire situation. And you're hitting on something so very important, which is we have the brains we have because of the genetic inheritance from our ancestors. Put simply, the reason you and I are here today is because our biological parents lived long enough to have children. And then their parents lived long enough to have children on back through human history. So brains that were organized a different way, that didn't protect survival, didn't make it to this point in human history. Do you get what I'm saying? So the way the brain is organized is what has allowed the species to get to this point. Not to say it's a good thing or a bad thing, but it's how we got here, is a brain that functions in this way. Great questions. Thank you, everyone. So we had an earlier question saying, well, you know, the left has words or most words, and the right has creativity. So how about something like a writer? Well, there is a band of fibers called the corpus callosum. It is an information highway that connects the two hemispheres, and thousands of messages per second are transmitted across the corpus callosum. So someone like a writer, like your example, they're getting their treasure trove of vocabulary from their left hemisphere, and they're getting their creativity from their right hemisphere, and the corpus callosum is allowing them to experience that seamlessly. Now you tell me your reaction to this picture. Do you want me to take a little bit of time and explain the parts we haven't seen yet? Or is this more brain anatomy than you want? You let me know. Are we okay to look at this, or should I go to the next one?
This is good for me.
You guys are doing okay? All right, so you will not hurt my feelings at any point. If you're like, enough already, I can always go to the next one. So, okay, well then let's have a look at what we already recognize. I just mentioned the corpus callosum. So you see that's a tan band of fibers that connects the two hemispheres. We've also talked about that large cerebral cortex at the top. And we've seen the frontal lobe, where we have judgment and impulse control. We've seen the parietal lobe, where we have sensory information and spatial awareness. We've seen the occipital lobe, where we have vision and our ability to read. The cerebellum is where we coordinate our body's movement. The brain stem coming up out of the spinal cord gives us basic functions of life. And tucked over here is the temporal lobe, where we have hearing, music, and language. So now let's look at the pieces we haven't seen yet. In the center of the brain is the limbic system. If you think, oh, did I get a question or a comment? I thought I heard a voice.
Are we moving to the yellow egg-shaped thing in the middle?
We sure are. Thank you
Okay.
for asking that. We are going to take a look at the center of the brain now. So exactly right, the very, very center of the brain. If you think of your brain like a cantaloupe, the limbic system would be the pit of the cantaloupe. So that's where we are. We're right in the middle of the brain. Okay. And thank you for the egg-shaped comment. I thought it looked a little bit like an olive green lima bean, but yellow egg, olive green lima bean, whatever works for you, that's where I'm going to start. It's called the thalamus. Now, what I'm going to do is just take a brief moment here and explain how your brain is working right now and every moment of your life. Okay? So, every moment of your life, you are perceiving things with your senses. What comes in through your senses goes first to the thalamus, that structure in the middle of the brain. The thalamus is the relay station for your senses. Here's what I mean by that. I'm going to say eyes as an example. My eyes bring optic stimuli to the thalamus. And the thalamus says, oh, this came from the eyes. Let me send it back to the occipital lobe for processing, because the occipital lobe is what processes vision. So the thalamus sends what came in through my eyes to the occipital lobe so that I can see. Then the occipital lobe sends it back to the thalamus. The same thing happens with what you hear or what you touch, what's coming, what you taste, what's coming in through your senses goes to the thalamus to be sent to the part of the brain that processes that sense and then sent back to the thalamus. So what we call seeing does not happen in the eyes. The eyes bring the stimuli to the brain, but what we experience as seeing happens in the occipital lobe of the brain. Okay, so something's come in through our senses. It's gone first to the thalamus. The thalamus sends it out to the appropriate lobe, to be processed, and then sends it back to the thalamus. Now, very, very important. Where it goes next is the amygdala. The amygdala is the small rust-colored pea-sized shape. The amygdala has your fight, flight, or freeze reflex. The amygdala stores your phobias and traumatic memories. In short, the amygdala is the center of fear and rage. So every moment of your life, the amygdala is asking two questions. Is there anything to be terrified of? Or is there anything to be enraged about? And if the answer to either of those questions is yes, then we never get up to the fancy frontal lobe where we have logic and reason. Instead, we go into fight, flight, or freeze mode. Now let's say that the amygdala is giving us the all clear. It's saying there's nothing to be terrified of. There's nothing to be enraged about. Then what I have perceived through my senses goes next to the hippocampus. The hippocampus is that circled lavender shape. The hippocampus is heavily involved with learning and memory. I said earlier that it takes a minimum of 8 seconds of focused attention to make a memory. The piece of the brain that is making the memory is the hippocampus. Memories are not stored in the hippocampus, but the hippocampus is what stores the memory and retrieves it. So to sum up what we've said, everything you perceive goes first to the thalamus and sent to the appropriate lobe for processing. Next, it goes to the amygdala to see if what you're perceiving is triggering any phobia or traumatic memory. If it's not, then it goes to the hippocampus to be stored in memory. Now, when you're born, your brain weighs less than a pound. When you're an adult, it weighs 3 pounds. The part that's growing and developing and maturing is not your limbic system. This limbic system that we're talking about, the center of fear and rage, does not mature throughout the lifespan. It's your inner child. The frontal lobes are what control the limbic system, but they're less active when we're sleep deprived or stressed. Questions? Okay, so we're just kind of laying a foundation for how the brain works, so we'll understand what happens when things go wrong. So a brain injury is when something changes the structure or function of the brain. Here's a partial list of things that can cause brain injury. It can be problems with blood or oxygen levels in the brain. Toxic exposure is the category for chemo brain, because chemo is a neurotoxin. Brain tumors can cause brain injury. And then you can have traumatic brain injury, which is caused by an external force, something outside the brain injuring it. A concussion, a gunshot wound, car crashes, and any kind of abusive head trauma. So taking an example like traumatic brain injury caused by an external force, that happens when the head hits an object or is hit, or if the brain is penetrated, or even if the head is never touched, but the body is violently shaken, causing the brain to move inside the skull. You can see in this picture that the brain is not secured in the skull. It's floating in the skull. So when you strike one side of the head, the brain bounces back and strikes the other. The brain is the consistency of Jell-O. So when it's banging around in there, it's scraping against the sharp, jagged ridges inside the skull. In this illustration, the top is the front of the brain. The bottom is the back of the brain. Do you see how the front and sides have the most prominent, sharp, jagged ridges? That is why when a person's brain is shaken up inside their skull, they'll have more damage to the frontal and temporal lobes usually, because that's the part of the interior skull that has the roughest surface. So I've shown you the brain kind of from a distance. Now I want to do the opposite. I want to go down into the cells of the brain to look at what's happening. And we're almost to our part on dementia, but just a little bit more on how the cells communicate and what happens when they're injured. Is everybody still with me okay? Okay, you're doing great. So
This is all physical.
oh,
This is
sorry.
I'm sorry, this is Dan. This is physical injury versus a chemical injury like chemo brain, right?
Correct. This is an example of a concussion. A concussion would be a diffuse axonal injury. I'm glad you brought that up, Dan, because brain trauma is cumulative. So if a person had concussions in their past and now has chemo brain, they're going to struggle more than somebody who never had any injuries in the past. And it works the other direction. Someone could have chemo brain. And just to give an example, let's say someone's feeling not well and they're unsteady on their feet and they fall and hit their head. So they sustain a diffuse axonal injury on top of what the chemo brain has done. Yep. So that's why we want to look at this as an example as well. So thank you. Thank you for bringing that up. So diffuse means throughout the brain. So like if you fall, it shakes up your whole head. You may not see that from the outside, but inside the brain is being shaken up, the whole thing. Axonal refers to axons. Axons are the long connecting fibers between nerve cells or neurons. So if you look down the left-hand side, you can see what happens in the brain that is not injured, not from a concussion, not from chemo brain, just working the way it's ideally meant to work. Neurons send signals. That's what neurons do. Neurons send signals. Your brain has 100 billion neurons, and they send signals to each other. How? Down axons. So a neuron sends a signal down an axon to the next neuron. And that's what we think of as the brain doing something. When you look in the upper right, you see zoomed in a close-up of when one axon ends and comes to the next cell. And you can see that there are these dendrites, these extra connections that sprout from the original axon. All I want you to know is this. The more connections you have between two cells that do something, the better your brain is at that thing. So athletes have more connections in the cerebellum than non-athletes. Whatever you do creates connections, and then those connections make you better and faster at that thing. So what happens with something like a concussion, maybe from a fall, is that the axons are twisted, torn, or broken, which impairs the ability of them to communicate. I want you to particularly notice illustration C in the bottom right. Do you see where the axon has broken? Does everybody see that? The broken axon in C?
Yes.
Okay. For context, an axon is very delicate. Think of a single human hair. An axon is 100 times thinner than a single human hair. Think about that. 100 times thinner than a single human hair. That is how delicate these axons are. And get this, they're hollow. Yes, they are hollow. So a broken axon does not knit back together like a broken leg. Instead, a broken axon withers and drops into the fluid that circulates in the brain. Can you picture that? You've got fluid circulating in the brain, and floating in that fluid are these broken axon pieces. And guess what? Now that fluid has to flow down the existing hollow axons. So what is going to happen when an existing hollow axon, just sitting there minding its own business, and here comes fluid in the brain that is brimming and floating with broken axon pieces the same size it is? What is going to happen to that remaining hollow axon?
You won't get the fluid.
It won't get the fluid. It's going to clog up the axon, right? Just like you can clog an artery. You're going to clog up the existing axons with the broken axons. And when you have clogged up enough axons, you have dementia. That is why people with a history of concussion and other forms of traumatic brain injury have an elevated risk of early onset dementia, because they've got broken axons clogging the remaining axons.
Hi, so I have a question.
Yes, please.
How seriously does one have to hit one's head in order to produce this effect?
Excellent question. Yes, what excellent question. Okay, now, force is measured by G's, meaning times the rate of gravity. So when you're hit by, let's say, 80 G's, that means you're hit by a force that's 80 times the force of gravity. That would be the equivalent of getting hit by a car going 45 miles per hour. In a typical football season, a player sustains more than 500 hits that are greater than 80 Gs. Now, people experience what would be called a concussion. They get a headache, they throw up, they're seeing double, they've got symptoms at different thresholds. So let's say a person does not experience it as a concussion unless they're hit with 100 Gs of force. Well, all those hundreds of times they were hit with 80 Gs, they were doing all of this inside their brain, even though they never felt any concussion symptoms. So 80 Gs is more than enough to twist, tear, and break axons in the brain. And people who have never had a single diagnosed concussion have been found to have CTE, chronic traumatic encephalopathy, where repetitive head trauma was never enough to trigger a symptom, but they had all of those hits that did this inside the brain. So it's not just contact sports, it's veterans, it's victims of intimate partner violence, anybody where their head is being shaken around a lot is at risk for damaging their axons and not even knowing it at the time.
What about falling once and hitting your head? On
Oh,
wood?
that's going to depend on your age. So when you are 30, your brain fills your skull. However, starting at age 40, on average, a person loses 1% of their brain tissue per year. I'm going to say that again. Starting at age 40,
40.
on average, a person loses 1% of their brain tissue per year. That means that by age 70, the average person has lost an inch of brain tissue. This is important for your question about falls, because when the person falls, now their brain is slamming against the inside of the skull, right? Versus if your brain is filling your skull, it's not slamming that inch and bouncing back and slamming the inch the other way. You see what I'm saying? So that is why people 70 and older have the highest rate of brain injury related hospitalization and death, is because there's more space inside the skull to slam when they fall. Versus if you fall when you're 30, it's not as likely to be so serious.
Okay.
Yeah, so see, I'm trying to be subtle about it, but what I'm sneakily trying to do is kind of encourage you to watch your step and, not have any tripping hazards at home and things like that, because I don't want you to fall, because sustaining a diffuse axonal injury is not a good thing on top of chemo brain.
I have another question. When you're talking about a fall that would injure the brain, it's obvious that if you hit your head, that causes a brain injury, but do you mean just any fall?
Any fall, yes, because a blow to the body causes the head to move.
Okay.
So the force is still reaching the brain, even if it wasn't a direct hit.
Okay, yep, that makes sense.
Great question. You're very welcome. So I said that a history of brain injury creates an elevated risk of early onset dementia. So what we've covered so far is a tour of the brain and brain injury. Now we're on to dementia. Dementia is an umbrella term for loss of memory and other thinking abilities severe enough to interfere with daily life. I'm going to call out two forms of dementia here as exceptions: vascular dementia and Huntington's dementia. Vascular dementia is caused by a lack of blood to the brain, usually a clot. Huntington's dementia is caused by a defective gene. Vascular dementia and Huntington's dementia are exceptions. All other dementia is caused by abnormal deposits in the brain. So Alzheimer's has abnormal deposits. Lewy body has abnormal deposits. Frontal temporal has abnormal deposits, chiefly in the frontal and temporal lobes, and so on. So what I'd like to do, if you're game, is show you how dementia spreads through the brain, how it does that, because that can help you understand the symptoms that you or another person might have. Are we up for that?
Sure.
Yes, okay. So I'm going to start with Alzheimer's. So this is the same brain anatomy slide we had earlier. I just made it a little bit smaller and fainter. So what I'm going to share now is how Alzheimer's progresses through the brain. Where does it start? The hippocampus. Alzheimer's begins in the hippocampus. We said earlier that the hippocampus is heavily involved with learning and memory. So what happens when a person has abnormal deposits in their hippocampus is they have trouble with short-term memory. So they ask a question or tell a story, and then a short time later, they ask the same question. They tell the same story. But their long-term memory is unaffected. So they know what happened when they were a kid. They may know what happened many years ago, but they struggle with what happened recently. Next, the abnormal deposits spread to the parietal lobe. We said that the parietal lobe gives us our spatial awareness. When these abnormal deposits reach the parietal lobe, the person gets lost in familiar places. Then Alzheimer's deposits go to the frontal lobe, where we have judgment and impulse control. So when the abnormal deposits spread to the frontal lobe, the person they take risks and act impulsively. And Alzheimer's continues to spread throughout the brain until it gets to the brain stem. And, let's say a person lives to this point, the way the person would die is when the deposits reach the brainstem, the person forgets to breathe. Because we said brainstem has the basic functions of life. So when it gets to that point, the brainstem just no longer has the lungs breathe or the heart beat, and the person passes away in that fashion.
Hi, so I have another question. So in terms of short-term memory loss,
Say that again, short-term memory?
short-term memory loss.
Yes.
So I'm familiar mostly from the book and movie about Alice, that with the pattern of, you explain something or you ask something and get an answer, and then you forget that you said that and do it again. But what if you remember that you asked but can't remember the answer, which sometimes, like, maybe I don't pay enough attention to the answer, or what, like, I'll ask about a date, and then I'll realize 15 minutes later, I don't remember what
Yes,
the answer was, but I
Yes.
remember that I asked.
yes. And you hit the nail right on the head. Most likely, that is not a problem with memory. That is a problem with attention, that you did not hold your attention on that information long enough for the hippocampus to store it. Yes. And I must tell you, in this day and time where we live, where so many things compete for our attention, it's very hard to sustain your attention.
And I
And so a lot of, yes, a
I
lot
don't
of times,
listen to my husband well enough.
so a lot of times we think we may have a problem with our memory, when truthfully the problem is with our ability to sustain our attention. So it's not that we couldn't retrieve it from memory, it's that it never made it to memory in the first place.
Okay.
But it also means that I think you said that as you age, you're not as able to sustain your attention.
Exactly right. So it's not technically a problem with encoding it in memory, but the end result can be the same if you're not able to hold your attention long enough for it to be put into memory.
And then some of us are trying to teach ourselves to pay attention. You know,
Yes.
when I'm putting my keys away, for example, you know, having certain cues,
Yes.
pay attention to what I'm doing.
Oh, so important. And I will tell you, I am shameless about this. I will talk out loud to myself, even in public. I will say, okay, brain, pay attention. Watch where you're parking. So when you come out of the store, you'll know where you are. Because otherwise, I might just pull into a parking spot, go into the store, come out, and then think I have Alzheimer's because I don't know where my car is. No, I didn't pay attention when I parked my car. That's why I don't know where it is. Not because I don't remember, but because I didn't get my brain's attention and hold it there for long enough to know that I had time to save that memory.
And what I know is that I remember not that long ago when I could do more than one thing at a time and still remember doing both of those things. Whereas now it's not that way. I usually really can't remember. If you try to do something automatically like you used to do, it just doesn't, I have no recollection of it.
That's a very good point. And again, that has to do with attention. The ability to divide your attention diminishes with age, and it also is impaired by things like chemo brain. And so, yes, it is important to kind of do one thing at a time, be present, focus your attention on what you're doing to get the best results. So I just want to briefly show another example of dementia. This is the CTE that I mentioned, the chronic traumatic encephalopathy, and it's associated with people who have had repetitive head trauma. I just wanted to make sure it's okay if I show slices of brain. Is it okay if I show slices of brain? Okay, I don't want to just inflict that on you. Okay, so what you're seeing here is tissue from 3 brains. The top row is each brain treated with a stain, and it turns healthy cells violet, and it turns the abnormal deposit cells brown. In this case, the abnormal deposits are of the protein tau, TAU. So what you're seeing here first is a person who died at age 65 but not of anything brain related. So what I want you to see there is that all those cells are violet. So something like CTE is not a natural part of aging. You don't just get clumps of tau throughout your brain because you get older. The second brain is from somebody who died at age 45. He happened to have been a professional football player, and he died at age 45. And you can see there that he has deposits of those brown tau proteins. And then the last brain is from someone who died in their 70s. They were a boxer. And you can see what I mean about it, dementia being progressive. Like as time passes, the abnormal deposits spread more and more. So I wanted to show you what it looks like in the brain, how it spreads. So with something like CTE, to start with, there aren't any symptoms. We talked about that before. Like things can be going wrong in the brain and you don't know about it right away. So what this is showing you that these isolated spots of tau start to build up mostly around the frontal lobe or the crown of the head. In stage 2, symptoms of rage, impulsivity, and depression begin to appear as the defective tau protein affects more nerve cells or neurons throughout the frontal lobe. Do you see it spreading? Do you see how there's more brown spots as we go? Stage 3 is marked, Stage 3 is marked by confusion and memory loss. The tau deposits expand from the frontal or top section to the temporal or side section of the brain. And look at this. I put this note here for you on the right. The condition begins to affect the amygdala and the hippocampus, which impairs emotion and memory. Stage 4 is advanced dementia. The brain becomes deformed and brittle, and cognitive function is severely limited. By stage 4, tau deposits have overwhelmed the brain, killing many nerve cells and shrinking it by roughly half its size. I feel like if we could see each other's brains, we would understand why we do what we do. Don't you agree? Like just looking at this picture, do you agree that the brain on the right cannot do what the brain on the left can do? Right? But we can't see each other's brains, so we don't know that this is what that person's brain looks like. My motto is, everyone is doing the best they can with the brain that they have. Everyone is doing the best they can with the brain that they have. If I had that person's brain, I would be doing what that person is doing. So let's talk about how to interact with a person whose memory is malfunctioning. This is the big one. Connect, don't correct. You want to connect emotionally with the person, not correct their memory mistakes. Focus on what is left, not on what is lost. We mentioned earlier that the left hemisphere has talking and walking. The right hemisphere has singing and dancing. So if dementia is degrading the person's left hemisphere, please know that people who can't talk can sing. People who can't walk can dance. Look for other ways of connecting with the person. This is a very important concept. There's something in neuroscience called the reminiscence bump. And this is what that means. I said earlier that the brain needs to pay attention in order to make a memory. And that the brain is most likely to pay attention when something is new and when it is meaningful. Well, for many people, between the ages of 13 and 30 are when they have a lot of new and meaningful experiences. Maybe their first crush, the first dance, they graduate from high school and they go off to college away from home for the first time. They get married, they have their first child, they start their first job, all of these meaningful firsts.
You left out first sex.
You're on.
I know, really?
Oh, I didn't quite hear. If there is a question, please ask. Where I was going with this was just the idea that when someone progresses in their dementia, they will think they are between the ages of 13 and 30. And when you know that, what they say and do makes a lot more sense. So let's say you go to visit an older lady, she has dementia, and she's upset, and she says, I have nothing to wear. And you think, what are you talking about? You know, she's wearing a sweatsuit, she's got a closet full of sweatsuits. What is she talking about? Well, if she thinks she's between the ages of 13 and 30, then she may be thinking, I'm going to a dance, I'm going to a party, I'm going to a wedding, and I have nothing to wear. So when you realize that the person thinks they're between the ages of 13 and 30, it becomes a lot easier to understand where they're coming from. And what you want to do is strive to be a comforting presence. It can be very frightening to have dementia. Sometimes a person can see and hear things that aren't there. They can be quite confused a lot of the time. So you're there just to be a comforting presence. You don't even have to say a lot of words. The person probably can't process a lot of words. So what you can do is just make sympathetic noises. Even if you can't understand the words they're saying, you say, mm-hmm, mm-hmm. You know, you take a page out of the playbook of husbands since time immemorial, right? You just say, uh-huh, uh-huh. And maybe you're not hanging on every word. Do you know what I mean? And you can match their tone of voice. You can mirror their facial expression. If they look upset, you can look concerned. If they look happy, you can smile. You're just there to be a comforting presence. You're there to connect with the person.
Yeah, I know. Okay, so I do have another question. It's about the connect, don't correct.
Yes.
So we're talking about someone who has serious dementia, right? So they may just be saying all kinds of things and you shouldn't bother to correct them. But as before we get to that stage, when we just say the wrong date or the wrong word or whatever, my inclination, of course, and my husband's too, is to correct the other. But I assume that's it. You're talking about something different.
Well, yes and no. Yes and no. Our memories are wrong a lot. And so it can really help in relationships to approach something with less of an aim toward correcting. If it's something crucial, like the date, absolutely. But if it was a slip of the tongue, we can just let that go. We don't have to correct that person.
How about asking if the person wants to be corrected?
Well, that's a good way to handle it. You know, would you like to be corrected? Yes.
Take us off.
Yes. Okay. So now let's think about something that a few of you have shared so far, which is kind of getting at, you know, how do I know if something's wrong with my memory or maybe the memory of someone that I love? Well, I mean, if you're concerned about memory, then I definitely would want you to talk with your doctor. But I also want to kind of give you a basic framework for understanding a few key ideas. Let's take the classic. You come out of the store and you don't remember where you parked. Most of the time, that is a problem with attention. The person did not hold their attention long enough on the parking spot to have the brain have a chance to remember it. Versus you don't remember what car you drive. That is memory. Do you see the difference?
Yeah.
Like, if you don't know where your keys are, that's attention. If you don't know what your keys do, that's memory, right? So where things are a lot of times is attention. Another thing you can watch for is language changes. Because we talked earlier how most of your vocabulary is in the right hemisphere. And, pardon me, in the left, I misspoke. And then the right has 100 words, simple words, swear words, and slurs. So let's take this example. Somebody says, I need to go to the hospital to do the test. Versus if the person says, I need to go to the place to do the thing. Now, you may say, but I do that second one. When I'm very busy and distracted, I say, oh, I need to go to the place and do the thing. You just said the operative phrase. When you're busy and distracted, when your brain is under cognitive duress, and it can't access your whole sophisticated vocabulary, it goes to its backup section where you've got simple words. But a person with a memory malfunction, they use only simple words, even when their brain is not experiencing cognitive demand. They're sitting alone with one other person. It's peaceful, it's calm, they're well rested, they're not hungry, they're not stressed, nothing's wrong. And they still say, I need to go to the place to do the thing. That is a sign of memory malfunction because it's using a simple generic word instead of a longer specific word. Another one would be getting lost driving. I gave the example in Alzheimer's that after the abnormal deposits leave the hippocampus, they go next to the parietal lobe, which causes a person to get lost in familiar places. But there's another thing that could be causing that. Sometimes when a person gets lost driving, get this, they are looking for a home where they used to live. Especially as time passes and they reach that point where they think they're between the ages of 13 and 30, they're trying to find the place that they lived between 13 and 30. So your hint is things like them saying, they must have torn down that ice cream shop on the corner. I always turn at the ice cream shop on the corner to get to our house. And you're thinking, there was never an ice cream shop on the corner. What are you talking about? Well, I bet you any money there was an ice cream shop on the corner of their street of a place they lived between the ages of 13 and 30. Now, I can see that I have used all of your workshop time. So we did have one other topic, which was brain health. And I want to give you a choice. I did cover this same brain health topic in the chemo brain topic from last September. So we can do one of two things. I can either refer you to that presentation, or I can kind of briefly give you the concepts. Like I said, I know I've taken an hour and a half of your time here. Either our fearless leader or anyone who wants to chime in with an opinion about what you would like me to do.
I'd like to be referred to the former presentation.
You said you can watch the former one? Was that what I was hearing?
Yes.
Okay, excellent. Well, then what I will do.
Wait. I have a suggestion. Maybe those who don't want to stay, don't have to stay, but those who can would like to. I would like to stay if it's only.
Oh,
10
okay.
minutes or
Well,
so.
that's a good
would
way to
too.
do it too.
Yeah.
We would too.
Yeah.
Okay, so how about this? For folks who are stepping away, I say thank you so much for being with us, and you'll get the whole presentation as well as a reminder to have a look at the one from last year. And then folks who want to stay with us will soldier on and cover brain health. Is that acceptable to the group?
Yes.
Yeah.
Okay, great,
Sounds
great
great. Thank you.
suggestion. So again, thank you for folks who are leaving us now. And again, the presentation will have my contact information, so you're more than welcome to get in touch with any further questions.
Good, I have a question. Okay,
Okay.
okay. Could I ask you a quick question now?
Oh, of course.
Okay, so this is like, is this somewhere where I can go read about it, look it up, whatever, so you don't have to deal with it? But it's about word reversals as opposed to the general word for this specific word, but like the pattern of, saying right instead of left or up instead of down.
Yes.
Yes. What is that?
What is that? Well, I mean, I have to say, with all the love in the world to the men on the call, neuroscience has such a sexist history. And I'm going to give you a term because that is the correct term. And I believe in giving you a correct term for you to look something up. But what you've described is something that, God help us, they named the ugly sister phenomenon, which means that when your brain goes to look for something, it gets close, but not quite it. And it thinks it's got it. And so it finds the ugly sister instead of the sister or word it was looking for. And so this ugly sister phenomenon, apologies, does increase with typical aging, but it accelerates in dementia. So it would be a question of degree, like how much is it happening? Because one thing that's very important to know is that young people make those mistakes all the time, but there's an important difference. Young people typically are not preoccupied with their memory, so they don't pay any attention to all the times that they misspeak. And I know this because I give talks every semester at Ithaca College, and they tend to be the traditional college age, young people, and they switch words and mess up all the time, and they don't think anything of it. So a part of it is, yes, it's happening, but unless you were tested, you wouldn't know, is it really happening more? Or are you just more aware of it because you're nervous? Does that make sense? So yes, it is a real thing. It's called the ugly sister phenomenon in neuroscience. Yes, it does increase with typical aging and it accelerates with dementia. But again, there's a certain amount of that that we all do throughout our lives and we just don't realize because we're not paying attention.
Besides having a sexist name, is it any more common in men or women? Do you know?
No, it is no more common in one than the other. It's just that most neuroscientists who were naming these things were men,
Were
and
men,
that seemed like a good
yeah,
name to them at the time. Yes, and some of my best friends are men, but I'm just saying, I think I could have come up with a better name than the ugly sister. Okay, I see two hands, David, then Sally. So David.
Oh, I don't know how to raise hands, so I just talk.
Unmute yourself.
At least for me, it's still showing you as muted, David. Oh.
Unmuted. Okay.
Now I see you unmuted. Okay, yes, please.
I'm 80 years old. I just retired from teaching at Cornell. And I've noticed maybe for the last 10 years, the first part of my memory that starts to go is to remember names. And
Yes.
it is progressively seems to be getting worse.
Yes.
And my question is, at what time does it become pathology that one should seek for testing, seek further help, and or is this just a natural progression of things and you just live with it?
It's an excellent question. So first, let me say that names, by which we mean proper names,
That's
so
right.
people's names, are throughout the lifespan one of the toughest things for memory, because without getting too technical, proper names are stored like in a little cul-de-sac. So instead of being out on a superhighway where they're nice and easy to get to, they're kind of tucked away where they're hard to reach. So it does become increasingly difficult to get to them as years pass. But in my opinion, it's not something to worry about until it gets to the level of your inner circle. Like if you don't remember whoever's close to you, you don't remember your wife's name, you don't remember your kids' names, you don't remember your neighbor's name that you've had as a neighbor for 50 years. That's when it's more troublesome. Throughout your life, every time you think of a person, you build a connection to their name. So if it's someone you've known a long time, and every time you heard, said, wrote their name was a new connection, then a lot of those connections can deteriorate and you can still get to that person's name. But if it's someone that you didn't know very well, then you never had very many connections to start with. So they could have deteriorated and they're stuck in this little cul-de-sac that's hard to get to anyway. So the short answer is anything that troubles you, you can see your doctor about. But to me, until it reaches the point that it is affecting your daily life because you don't know the names of people close to you, I would not consider that pathology. Does that answer it?
Yeah.
A little bit?
Yeah.
Okay. And let me just say, well, the biggest enemy of memory is time. If you make a memory and proverbially speaking, you put it up on the shelf, it will fade away. And I mean that literally. the strands that form the memory circuit will disintegrate. So the way to remember names is to quiz yourself, to make your brain retrieve the name, because then it's got to build a new connection, which will make it easier to get to the name the next time you need it. Okay. Sally, what is your question?
Actually, I've got a sort of a comment slash question and then another question. The first is losing words. I feel sometimes like I've got a big soup cauldron in my head and the words are floating around and I have a spoon and I'm trying to get the one I want, and sometimes it will float into my reach and other times it'll be sunk in the back. And words that I'm after will come back later. What's going on with this delayed search mechanism?
Yes, yes.
That's
Well,
happened to me when we were watching it.
yes, your brain does not give up easily. So, well, actually, let me say it this way. It is a sign of brain health that your brain does not give up easily. In other words, as something like dementia progresses, if a person can't think of the word they want, it does not stick with them. But in a brain that's functioning well, the brain does not call off the search. So even though in your conscious awareness, you're no longer trying to find the word, the brain in a parallel level of consciousness is still looking for it and probably will find it at 2 in the morning or some other inconvenient time, right? So the brain is going to keep going. Now, if this troubles you, I am a big fan, and research bears this out, of talking out loud to your brain. Research shows that your brain believes what it hears your voice say more than any other voice. So I'm a big fan of talking out loud. So you say out loud to your brain, you can let this one go, right? And a certain amount of the time, your brain is going to listen to you and call off the search and not try to find that elusive word.
Great. Thank you. My second question is, I don't think I had chemo brain, but chemo basically killed my hearing. So the reason I'm not looking at you is I'm looking at my phone, which is closed captioning what you're saying.
Okay.
And I've been reading that losing your hearing and or your eyesight makes you more prone to developing dementia faster. And I'm wondering what the mechanism is for that. Why that's true.
Why that's true is because I've been focusing a lot on the word attention, right? You need to pay attention in order to form a memory. But you know what? There's a step before attention, perception. You must first perceive what is coming in through the senses before the brain can attend to it. So by not being able to perceive as well through those senses, you now are not attending to them because you're not perceiving them. So now memory is not being stored or retrieved.
So
You're welcome, Maya.
my theory was that because this is what I'm experiencing sometimes when I'm deaf, I just have to let the conversation go. I can't get it. And it seems to me that the deafer you get, the more you have to let go. Other people are perceiving me as stupid when I'm just deaf. And I'm wondering how much dementia is how much deafness, or blindness is misperceived as dementia.
That's a very good
I don't know if
point.
there's a way to get at that, but
Yes. Well, ideally, the assessment mechanism should account for perception differences, but they don't always. I will say, Sally, that more often it goes the other direction, where dementia is missed because a person seems able to kind of fake it through social interactions. So a classic example of this is that a person is suspected of having dementia. And so their loved ones say to a police officer, we want you to go do a wellness check and go visit this person. So the officer comes to visit the person and says, hello, good evening. And the person says, good evening, officer. Oh, it's a cold one tonight. Yes, it is. I think it's going to snow. I heard that too. Small talk. And the officer thinks, oh, this person is okay. And after the officer leaves, the person wanders down the street and gets lost. Why was that dementia missed? Because the person can still do the pattern of small talk conversation. Why? Because they've done that probably literally hundreds of thousands of times throughout their life. So they still have connections to how to do that. Versus if the officer had said, what are you making for dinner? They would have probably realized, oh, this person is not aware of what's going on, because that's a little bit more specific of question than small talk about the weather. So you're describing dementia being diagnosed when really it's a perception issue. And I agree that that can happen. I'm just saying statistically, it's much more likely to go the other direction, where the person has dementia, but they can keep up a social facade and it is not obvious that they don't have their short-term memory working. Yeah. I saw a question from Al. Let me just double check and check in with the group. Is everybody who wants to stay for brain health still okay if I take Al's question? Because I'm happy to do that, or I can actually ask Al to call me separately. I don't want to lose people. I don't know how long you can stay with me. So is everybody okay if I take, not to pick on you, Al, but just to take Al's question? Is everybody still okay? Okay. Yes, please, Al.
So actually, it's a combination of a question and something I know. So I have bad hearing. I also know a lot about acoustics. I've taught it with people who know a lot more about how the brain works on it than me. And I can explain probably something of what was being asked before about the catching things in conversation, because I have exactly that problem. Basically, hearing loss, at least the kind that I have, is caused from loud noises. So it's trauma to the what I call hair cells. And what that means is that the signals from my ear that go to the brain, and you described very well where the signals go and how they're processed. When they go there, they're incomplete. In other words, the ear just isn't sending along what it expects to have.
Yes.
And I always look at it this way. It's like looking through a mesh at something. Bits of it are there, but to look through it, you have to figure out what the rest of it is. And so it takes a long time to process things compared to a normal person. And if people speak slowly enough, clearly enough, I can follow it. But even if they're perfectly clear and they're fast, I can't follow it anymore. And I've been using subtitles too, and I never thought about using them on my phone before, but I'm going to do them. So thank you for that hint.
Yes, yes. Oh, thank you, Al. Thank you. I must tell you, I am having a blast, and I thank you. You asked such good questions, and you have such good comments. So just one other quick little comment about memory. I said that time is the biggest enemy of memory. The way to keep a memory working is to retrieve it. If you make a memory and never visit it again, it will disintegrate. Language is a big culprit for false memory. So the way we describe things affects how we remember them. There's a lot of famous research for this. One of the famous ones was having subjects talk about car crashes. And so they would have the subjects watch a car crash, and then they would ask them, how fast was the following car going when it struck the first car, or collided with the first car, or crashed into the first car? And based on the vehemence of the verb they picked, people remembered the crash being faster and faster. So language is a big culprit for remembering things differently. It is easiest to recall things when the physical setting of recall matches the original setting when the memory was made. You may have noticed, like if you ever watch shows on TV, they take a celebrity back to their childhood home and they ask them about their childhood, right? Because it's a lot easier to remember sliding down the banister when you're standing in front of the banister. So when you're in the physical setting that matches where the memory was laid down, you will be able to recall it easier. That is true emotionally too. Your emotional state determines the memories that your brain serves you. So for instance, when you're in a happy mood, your brain brings you happy memories. When you're in a depressed mood, your brain brings you depressed memories. You can see this in relationships. When you're happy with your partner or your friend, it's very easy to think of lots of things that you like about that person. Conversely, when you're mad at your partner or your friend, it's very easy to remember all the things that they've done that bother you. Now, they're the same person, of course, but which memories are we being served from the brain? We've talked a lot today about the hippocampus. Chronic stress kills cells in the hippocampus. Isn't that a bummer? But good news, daily meditation for 30 minutes builds a larger hippocampus. So to counteract the cells you're losing from chronic stress, 30 minutes of daily meditation gives you a larger hippocampus. And we need that because that's the structure that's going to let us store and retrieve memory.
Wow. Explains a lot of things, doesn't it?
Okay, brain health. Now my standard disclaimer. If there's anything you have any questions about, I definitely would want you to talk to your doctor. But these are 6 tips for maintaining brain health. They're research-based, so nothing too controversial, I don't think, but very important things to maintain the health of your brain. So first up is nutrition. Your brain is made of omega-3 fatty acids and protein. So the brain tissue. So it's important to eat things that have omega-3 fatty acids. So I'm talking about things like fatty fish, like salmon or tuna. You can also have omega-3s in avocados or olive oil. Nuts are a good source. Walnuts have more omega-3 fatty acids than any other nut. And I also like walnuts because to me, they kind of look like little brains, you know, they have a wrinkled cortex. So it helps me remember that they're good for the brain. Of course, we want vegetables,
There's
we
your
want
favorite.
fruits,
Yeah.
right? So we need to feed our brain. If none of those appeal, red and black beans are excellent for the brain.
Yeah, those are really
And
good. I like those.
mushrooms, mushrooms,
Look at
excellent for the brain.
mushrooms.
Yes.
Same for cancer. It's like it's good for you in general.
Then, along with good nutrition, we need water. The brain is 75% water. So we need to drink water to keep the brain hydrated and working.
Excuse me.
Exercise. I just mentioned that daily meditation grows a larger hippocampus. Well, so does exercise. Exercise gives a person a larger hippocampus than their peers who do not exercise. I'll give it to you this way. The more you sit, the smaller your hippocampus. Now, I don't say that to shame you. I mean, if you, I understand what you're saying about cancer, physical capabilities. If you're not capable of exercising, I'm not shaming you. However, if you're capable of exercising, then I would love to gently talk you into exercising, because that is excellent for your hippocampus. It grows your hippocampus, and we need as big a hippocampus as we can get to keep our memory working for as long as it can. Okay, cognitive rest. Cognitive rest means letting your brain be inattentive, right? We said that's what your brain likes to do. It likes to be inattentive. Let your brain daydream. Let your mind wander. Now, you don't have to be physically at rest. You could be walking. You could be doing yoga. You could be swimming. You could be baking cookies, but whatever you can do easily, you don't have to really focus very much on it. It kind of comes naturally. It's an enjoyable thing for you to do. So I'm giving you permission to goof off, because it is during cognitive rest that your brain does three important things. Number one, your brain takes out the trash. In other words, during cognitive rest, your brain removes waste products. And as we saw earlier, dementia results when the brain does not clear away deposits. So we want to allow our brain cognitive rest so the brain can clean up. The second purpose of cognitive rest is to organize your memories. It's a lot easier to retrieve a memory that has been stored in an organized fashion. And third, during cognitive rest, we boost our creativity. Have you ever had this happen? You're trying to solve a problem and you think about it, think about it, think about it, think about it, and then you kind of give up. And you say, that's it. I'm going to call a friend. I'm going to watch a silly TV show. I'm going to go for a walk. And you're living your life. And then boom, there it is. There is a part of your brain that is only active during cognitive rest. And it is a part of the brain specifically for creative problem solving. So you can think about your problems, but it's also good to let them go at a certain point and then let your brain during cognitive rest figure out the answer for you.
Can I just ask quickly, is
Sure.
sleep, isn't sleep the same, is it different from sleep, would you say?
Excellent question. Sleep is cognitive rest. However, if the only cognitive rest your brain gets is during physical sleep, you're not getting enough cognitive rest. The brain is extremely busy during sleep. So it's really not the amount of rest that we're talking about here, where you're just letting the brain zone out.
Excellent, fascinating.
Yep. So yes, I mean, you think about it, from the time you first exist, your brain never stops working, right? Until you get to the office, right? And then it stops working. Or whatever it is for you. But you know what I mean? But so, like I said, even during sleep is a very busy time for the brain. So we have to let the brain rest during waking hours. Now, I'm going to give you the flip side of the coin. Just like we have to let the brain rest, we have to challenge the brain. So sometimes people ask me, you know, what are the brain exercises that help with cognition? The first thing I'm going to tell you is that you do not need a memory boosting app. None of them have been shown to improve your memory in real life. In other words, if you use a brain boosting app, it will make you better at that app, but it will not translate into real life. Now, when they come up with one that does translate to real life, I'll be sure to tell you about it. But right now, there isn't one like that. So you don't need to worry about getting a special app. These are the brain exercises that you can do that will help your brain. Number one, pay attention. Like I said, the brain by default is inattentive. So when you make your brain pay attention, that is mental calisthenics. Forcing your brain to focus on something is excellent brain exercise. Using all 5 senses at once. So a good example there would be something like cooking, right? Because you can smell and taste and touch and hear all at the same time. That's an excellent brain exercise.
Making salads.
And we've talked a lot today about memory. So I said earlier that if you just put a memory on a shelf, it's going to fade away. So in order to get your memory working, you need to retrieve things from your memory. So here are 3 excellent examples. When you go to a new place, when you get home, draw a map and include as much detail as you can of where you went. When you meet a new person in the morning, notice 4 things about that person. And then that afternoon, try to write down the 4 things that you noticed about that new person. Another thing you could do is take out a piece of paper and just pick a letter. You could pick the letter G, for instance, and just list as many words as you can that start with that letter. Do you see how in each case you are retrieving the memory? You're not just storing it, you're quizzing yourself. You're getting the memory back. And notice what they all have in common. They all involve writing. Writing encodes memory in the brain stronger than any other method. So when you write something, the circuits of the memory, well done, Sally, the circuits of the memory are stronger than if you hear it or read it. I mean, hearing and reading is great, but when you really want to remember something, physically writing it has been shown to be the most effective method for encoding it strongly in the brain. Speaking of reading, reading is excellent. It makes you use lots of parts of your brain, and having in-person conversations. I realize with COVID, you may not be able to do that, but if you're able to, if your doctor says, you know, you're allowed to be outside with other people, you just can't be inside, you know, whatever rules they give you, I want you to follow. But it's very important to have in-person conversations with other people, because there are entire networks of your brain that are only used for in-person interactions. So if we're not around other people, those parts of the brain are going to atrophy. If you don't use a part of the brain for long enough, the brain stops sending blood to that tissue. And when the brain stops sending blood to that tissue, the tissue dies. So I know it's an old one, but a good one. Use it or lose it. Whatever you want your brain to be able to do, you have to do that thing so that your brain knows, hey, I'm still using that tissue. Keep sending the blood to it. I'm still using it. Does that make sense? And last brain health tip is connection. Even if you can't be physically in person with someone, you want to be emotionally connected to people. Your brain needs other brains. If you don't want to think about it as being around other people, okay. Think of it as taking your brain for a walk to see other brains. Your brain needs to interact with other brains in order to function. Yes, Sally.
I'm wondering, I'm going back to this one-to-one interaction, and I want to mention that the first monkeypox case in Tompkins County today has been announced.
Oh boy.
And also I am on the autism spectrum, very late figuring that out. But I'll tell you, Zoom and phone are so much easier for me than in person, that I've actually been happier in the pandemic than most of my life. And I'm wondering how I balance that with this, what you're saying, I'm supposed to be there interacting with people, which is really tough under the best circumstance.
Right.
So just throwing, how does Zoom and phone compare to you know, touching, breathing on other people?
Well, I'm with you on the holding off on touching and breathing on. I agree, we want to be real cautious about that for monkeypox and COVID. I have not seen, I've been assiduously checking, and I have not seen any research comparing in person with Zoom in terms of brain health, but with completely respecting what you're saying and saying that that sounds like it's working out great for you, I'm all for it. The only caveat I want to offer is that I said things happen in the brain in person. I'll just give you one small example. When you're around other people, and again, I don't mean smushed up next to them, but when you're in the presence of human beings, one thing your brain does is smell other people. You don't have to sniff them. In fact, I'm asking you not to sniff them. You don't need to sniff them, but without you doing anything, your brain smells other people. And would you believe your brain can distinguish, are you sitting down? 1 trillion smells, trillion with a T. By contrast, you can only distinguish 2 billion colors, which is still plenty, but smell beats it out of the water. So when you're around other people, again, not smushed up next to them, but just in the presence of human beings, one thing your brain is doing is smelling them, and smelling them in intricate detail. It's performing very complex calculations and algorithms to get their exact smell. And you may say, well, why do I care about that? Because the olfactory nerve goes directly from your nose to your hippocampus. So keeping your sense of smell working is part of the infrastructure that keeps your memory system working. So again, not saying you should change what you're doing, Sally, but just to say there are things that our brains get from being in the physical company of other human beings that they don't get through Zoom or phone. Now, again, that doesn't mean that it's worth it to do it to you, but I just like to give you that context so you can kind of weigh your options. And I say again, talk to your doctor about, you know, what they think is best in your situation.
Actually, I'm not totally isolated. I have a very comfortable and wonderful husband who is around a lot. So I have him.
Excellent. Excellent. Well, that definitely counts.
Yeah, and without him, it would be really, really hard. But and I can't smell anybody in my P100 mask, which I am now totally in love with.
Okay.
Anyway. So,
and you make a good point, Sally. You know, everything's a trade-off. I agree with you on that. And so it sounds like, you know, you've arrived at an approach that is suitable and working very well. So yeah, I definitely don't mean this to come across as, you know, something you should do. More just to say, put this in your thinking cap, share it with your doctor, give some thought, and think how that works for your brain health.
thank you.
You're very welcome. Well, troops, you made it all the way through to the end. Congratulations. So just to briefly sum up, by default, our brains are inattentive. To remember, we need to pay attention. We are most likely to remember things that are new or meaningful. So if we want our brains to keep working, we need to have new experiences. We need to imbue those experiences with meaning. When we're interacting with someone who has trouble with their memory, our motto is connect, don't correct. In general, again, whatever works for your own relationship, you do that. But in general, that's how we're approaching it. And I end where I began by saying that yes, memory matters, but we find that even when memory is not doing everything that we might wish, the things that really matter in life, like love, persist. Okay, folks. I mentioned that I'm going to share this presentation with Jen, and you'll see that I've got my contact information on the slide. Hold on to your hat. I'm going to stop the share just so we can see faces if anyone wanted to say a face. And I cannot believe that anybody is still with me. You've been such good sports. I did not mean to go overboard. I clearly miscalculated how many slides to do, but I just thank you so much for having me.
It was so much fun. It's great.
Oh, good. Well, I love the brain, so I am not a good judge of what can fit because I'm always trying to shoehorn in one more concept, you know?
It was really interesting, Jessica, and it's amazing that you hung in there for such a long time without getting exhausted.
Oh, thank you.
Thank you. Thank you.
I want to
You've
thank
been a wonderful group. Oh, Jen, you had shared that we may stop the recording just in case there was any question